Hi, thank you for coming. I'm Tsm, and I'm gonna talk about the how something the Samsung Pay to implement its Samsung Pay and the sorry and what's the internal system mechanism inside the Samsung Pay, and also I'm gonna talk about the mistake that Samsung made and by Samsung made and also by the third party developer. So who am I? Because this is the first time for me to give a speech here, so I'm quite nervous and I was struggling how to introduce myself until I landing in London. And when I take a taxi, and after some conversation, the taxi driver just told me, "You remind me of Jack Ma." So that I think some of you might know me, and I'm from Tencent Shanghai Lab, and I'm a security researcher. And oh, sorry, this is my email, and you can contact me if you have any questions. So I'm focused on the embedded devices security, and especially on the software and the firmware reverse engineering. And now I'm just transferred to some IoT security. And I'm also a big fan of Linkin Park, so the rock and roll. Yep, let's start. So in this topic, I just divide the topic into three parts. And the first part, I'm gonna talk about what is Samsung Pay. And the second part is I'm gonna introduce the architecture of Samsung Pay. And on the final part, I'm gonna talk about how to steal money from Samsung Pay, and is it work or not? So if any one of you have used the Samsung Pay may get familiar with it, but I still gonna talk about some what is Samsung Pay. And in my opinion, Samsung Pay consists of three parts. And at the top is magnetic card, and with SE, which I'm gonna talk about later. And the fundamental of Samsung Pay is the tokenization technology. So let's get started with magnetic card. And you might know magnetic card technology was used for the first generation bank card, and now is still using for some room card. And in the case of a bank card, it consists of three tracks physically on the card, and the most important part of these tracks is the track. The second track is track 2, and when you are trying to do a transaction or a payment, and the track 2 is the only information transferred from to the post terminal. And as you see, this is just an example of track 2 information. The first part we call is a primary account number. We call it PAN, PIN. And the second part is some kind of information. Is confidential information. You have to keep it secret. And so once the track 2 data leaked, and someone can duplicate your card. And so that's how the card schema work. And let's go to the MST. MST is just kind of a technology to simulate a magnetic card. So it's using the generating a magnetic field to just simulate how the information on the card. And this technology was invented by LoopPay, and now this company was bought by Samsung, and the technology is also ported to the Samsung Pay. So this is just an example on the magnetic card. If we put some magnetic powder on the card, and we can see some lines, and with different just some of thin and some fat. So that's the pattern of the information stored on it. So I extract some a picture from the patent of the MST technology, and this is how the MST work. And if a smartphone equipped with an MST device, so the smartphone will will pass the data to the driver inside the equipment, and then the driver will generate signal depending on your data, and the post terminal will just capture the signal and decode it, and do some calculation, and then transfer it to the transaction center. That's just looks normal than just the same as the traditional transaction. And however, the MST technology, the energy they transferred is quite high, so anyone around the device can capture the signal. So to overcome this shortage, and Samsung introduced this technology we call is tokenization. Tokenization technology is kind of the technology to process sensitive data, and this is just kind of like you get your sensitive data in, and then give out some random-like data out, and the tokenized number can be verified but cannot be reversed back. So that's the advantage of this technology. But how to if you develop a payment or a mobile payment, you have to do some storage to store some stuff. So where to store the data or others? And Samsung deployed the SE, secure element. This secure element is kind of a chip, and this chip is quite high, have quite high security level, and you can put your data and into it, and theoretically no man can extract it, and the calculation was done inside this chip, so all your sensitive data cannot be out of the chip. There are three types of secure elements, and the first type, as you can see on the right, and the first is embedded type, and it's just a stick on the PCB board, and the second one is just it's kind of a SIM card, and it have the same function of a SIM card, but with secure element built in. And in China, some telecom providers will just provide this type of SE to give they cooperate with some bus company or the subway company, and then the end user can replace the SIM card, and then they can use this SIM card as their transportation card. So that's the application. So and the third one is just kind of looks like a micro SD, and the secure element is just built in it. And it's not quite common to see the application of this type of SE, so I didn't find any example on it. And in our case, Samsung used the first one. So the chip is just on the PCB board. So as I mentioned before, some calculation was done inside the secure element. So it has to be some program inside it. And from the point of software, where the SE just looks like a smart card, so it has a OS in it. So we call it card OS. And upon the OS, there are a lot of applications running on it, and all of these applications was developed by Java. And this is just some features of this. And one of it I want to mention is the author entity can communicate with these applet with a protocol called APDU, Application Protocol Data Unit. So that's the background of how what is Samsung Pay. So let's go forward to see the architecture. I use pyramid forms it's quite dark, to show the architecture of Samsung Pay. And the bottom is we know is Android apps, and just the Samsung it's just apps, and the higher level is some labs from the native and used for the communication and the crypto stuff. And in the kernel, there are some drivers inside, and to work with just do some work inside the level. And there are some trust zone applications running inside this level. And the top is SE, and there are still some applets running in SE. So let's go through each level to see what's the details of this. And the first component for an Android app level is some Pay stuff. As the name implies, you can just see it's just a stub, and without some function. So it's the function of this app is just to install these three important components. And when I doing the research, I found that if you don't have these stuff, it still work. You can just install all of these apps manually, and the Samsung will always work. And above that is main app and the framework. The main app just provides the UI and the code to communicate to do the card management, and it stores some informations and configurations into these files, and it also maintains several SQLite database. And the account of a SQLite database depends the region you are in. So in China, we have about eight database in it, and most of the data was encrypted and by the private algorithm. And the framework is the main function for the framework is just to provide the communication to the trust zone and to the trust light. And I don't know what the other regions implementation, but I found inside the Chinese version there are the trust light binaries are binded into the framework, and so that's the framework, and when you are doing the doing the payment, and all of the some of the binaries will be loaded into the trust zone and will be run inside. And here is another important component called Tsm Service. I think the full name is Trusted Service Management, and this service is just a client to the bank your card registered. So it's a bridge between the bank and the Tsm Pay. And in China we have the version provided and signed by China Union Pay. And the function of this service is just provide the enrollment, just enrollment your new card and download your card and update some stuff and to revoke or and delete it, delete the work. And this service, as I said, is just a client, so it's communicate with with your bank website, and so theoretically, if Tsm Pay wants a launch support on some certain region, and the only thing they have to do is just to make Tsm service for this region or for this bank. So that's the character of inside the Tsm Pay, and this could be the last component of inside the some Android app, and we call it SKMS agent. SKMS agent represents the Samsung Key Management Service Agent. Is the components communicate with some. This could be the only components communicate with Samsung Web Server, and I don't know whether is mistake or something. I found some clear code version of this, so I can reverse. I can just use the symbol. There's a lot of symbol in it, and this agent's just doing the SE initialization at the very beginning phase, and these work only done in once. So. When you doing some payment, and it will also collect some SE information for the further use. And here is just for APIs for interface to the native, and the first two just used to communicate with a trust light in trust zone when you are doing the payment, and the third one will be used to send some commands to the trust light, and I will mention later. And so that's the interface, and here is the relationship between all the components in the Android app level. As you can see, in the center is the main app, and to go up is just Tsm Service, and this region just communicate with the out server, the web server, and the bottom part is just coming to talk to the lower level, like native components. So that's it. And so let's look into the Android native. Android native includes some includes some labs. So that is some a shared library, and the core of these labs is labmcclient.so, and the meaning of this lab is Mobi Core Client lab, and the Mobi Core is just the name of a trust zone or operating system. So this is just the communication lab to talk to the trust zone, and there are also a daemon to just for the communication. In this daemon is you can connect to the daemon by the local socket, Unix socket, and then you can control the daemon to talk to the driver and by writing reading or IO control code and do some control or management stuff. And there are also three device interface inside for these, and you can see the first two is just provided by the Mobi Core driver, and this is just you can set some behaviors for the driver, and the last one is the interface. You can control the MST device, and you can turn on and turn off the MST device. Then, so you can when you to do the payment, the program will just turn on the MST. So just enable the feature. And let's go to the kernel. There are three drivers in this kernel, as I mentioned. The first is the interface for the user land, and the other is Mobi Core kernel driver. Is just driver talk to trust zone, and this driver is just control the MST device. And fortunately, we have all the source code, so you can download from the open source website from Samsung. And in this table, I just summarize the command ID for control the MST code. And you can see the first two just to turn on or turn off the MST device. And these three, I didn't find any use on it. It could be some test feature and cut off for the user release. So, and these send tests are used in the test the test program. If you can launch the test program, and it will just send this command, and the MST device will just give out the test signal and to test the whether the MST device is work or not. And let's go to see some trust zones stuff. And as I said, the name of trust zone is Mobi Core. Is a closed source OS, and in this level is doing some authentication or secure storage, and the application running in this level, we call it a Trust Lite, and the Trust Lite for payments is not encrypted but signed by Samsung, and so like all the others, all the applications have entry and accept the two arguments. And the first is the TCI, and the TCI is just a pointer to the word shared memory. This shared memory can be used by both normal word and the secure word, and they share they can share and exchange the data from this memory, and the length is just the length. And after the trust light loaded, and it will do some initialization to ensure the environment is correct, and then it will call this API just to wait for the wake up from normal world. And so when you are using the native process TA command, it will send the command to the trust light here. So let's go to see some information of a secure element. So when I start doing this research, I can't find any specific information about the secure element used in Tsm Pay. But when I start to make these slides and I tried again to search some information, and then I found this because some of customers just avoid the NDA agreement. So they leaked some about 80 pages of the information of secure elements, and some of items I want to mention is the ISA instructions is 80C51, and it have 1.2 megabytes flash inside, and the SE it was integrated into the NFC controller, so you can't see any chips from the PCB board. But to communicate with the SE directly, and it's just give out a SPI interface connecting directly to the SE, and from the document I found that the SE have five operation mode, but the first three was disabled when the using for a product. And if you are familiar with the common character, you will be this number will give you a sense how the secure element secure, and this is pretty high level. And this is just sorry. This is just a diagram of this secure element, how it's the inside. So I don't want to go through it. So it's just you can, and from the software we can the SE have a CardOS inside, and this operation system was regulated by a global platform, and so the OS was just follow the instruction how to build a secure secure operation system and how to do the protection. And there are two concepts that I want to emphasize. The first is a security domain, and the second is a secure channel. Security domain is what you can imagine the secure element is just a house, and the secure domain is just kind of a room inside the house, and we can't the applicant run inside the house and cannot talk to the others inside the room, and all the configuration data was also inside this house, inside this room, and the secure channel is is built upon the IPDU, and they add some commands on the commands and on this protocol, and this all of these commands is just to help you to do some negotiation and authentication. And after the authentication finished, and a session keys will be generated by the previous package, and the latest package will be encrypted by session key. And the root of this secure channel is depend on the keys inside the SE, and only known by SE and something. And so in a word, I just go through the architecture of Tsm Pay, and it's quite a lot of layers in the well-designed the Tsm Pay. And in the following pages, I just want to focus on these two layers, because most work appeared here. So how to steal money from Tsm Pay? We just think about two scenarios to do this stuff. And the first is from the remote, and the other from the local. And let's go to see the first scenario, the payment. So how does work inside when you're doing the when you're doing the payment? And this is just a brief introduction of how the user guide to do the payment. And and Tsm Pay will release both MST signal and NFC signal at the same time. But the MST signal is quite easy to to see. So we are focused only on this. And if you have heard of some other research on the Tsm Pay, and there are lot of reports on how to capture the MST signal. So I just pass through this page, and to see we are only focused on how the signal and how the token. And you can see, you may notice in this signal, the first the tail and the leading part just looks the same. Yes, these are the zeros, and these zeros just to help the readers to organize the signal was released, and we'll mention later. And in this picture, you can see these are all the identical signal with different amplitude. And in China version, I found a different implementation of the token. And when we're doing the research, we found Tsm Pay didn't use any internet access or cellular to generate the token. So it's the most possible way they are synchronized is by sequence number. And this is the sequence number, and you see, and for each time is increased by 1. And so this behavior inspires us. Is it the algorithm for generate token is by some random generator with a seed, and then they can synchronize with just a sequence number. So we go into to see how these token generate. And the token generate is quite important for a mobile payment solution. So Samsung use layers model to just minimize the attacking surface. And most work and just in trust zone and SE. And in this progress, we found two procedure mainly two procedures involved, and all the yellow part is the parameter accepted from the userland. Let's see the start pay. This is just the workflow of this procedure, and the first is get authentication result. Just check if you have input the password or use the fingerprint or something, and then it converts the parameter we call it AID is the ID for the applicant inside the SE, and it's just and then it's open the SE device, and this is through the SPI device interface I mentioned before, and then it will check the pay mode. The pay mode is just for is NFC pay or MST pay, and after all the check passed, it will just send a APDU command. The command could be called the get track data, and the track data is just call the applet inside the SE and to generate the token, because the token is just a part of the track data, and after that it will check whether the SE is valid or not. The track data is valid or not, and then it will copy the data to the word shared memory, and then wait for another command. It's called transmit MST data, and to do the transmit MST data, it's accept one parameter, and the parameter is to generate the leading and the tail zeros as we see in the picture, and the head and the tail are all also zeros, and the first they're gonna check the data, and then encode it with the data with the chassis of track 2, and then adjust the data with just adding the tail and the leading 0, and then send out this signal. This is how the MST how the payments work. So in this stage, we count. We found the algorithm for generate token is inside the SE. So at this stage, I just can capture the signal and replay it if it's not used. But if the token was used or expired, we can't have any attack. So here comes the question: can we get the algorithm inside the SE and generate a valid token of the phone? So we start the second approach. So the second approach is about registration, because when you enroll your card inside the Samsung Pay, you have to register your bank card in the app. So this is wizard how you register your card inside the Samsung Pay. And the first, you have to input or let the camera to read your primary account number. This is the bank card, the number, and then you have to enter some information of this card. And if you're using debit card, you have to input the password for this card. If you are using credit card, you have to input the security code. And after you input all the information, and here is come the terms and conditions page, and you have to agree it, and so it will go on. And once you agree with the terms, and you you might pick up a way to do the identification. That's just to let the something to know this is you to do this do this operation. And the mainly method is just to send you some one-time password and to verify you are the guy to do the operation. And once all of these done, and you have to wait and to wait for the download and wait for the your card to be activated. And so that's the general progress for registration. So, but what is inside? We were just to do some reverse engineering on this progress and to see what's going on. And before I go through the progress, I just want to see some say some the advantage and the disadvantage during the reverse engineering. I found the something do, and when the app launched, they will check the environment and to see if it's it is safe to launch, and Tsm is highly relying on the NOx system, and the NOx system is the base of the security system of Samsung mobile phone. Once this system corrupt, you cannot launch the Samsung Pay app again, and it will also do some checks both on the packets and the binaries. And but what Samsung doing bad is it's locked all the action they are doing on to the logcat. So you can just monitor the logcat and see what they are doing. And second, they locked all the decrypted packet, HTTPS packet into the logcat. So you don't even have to do some man-in-the-middle attack to decrypt the packet. And then most important is there other information leaked in the logcat. So so this is the progress inside the app that when you're doing the registration. And the first is will collect your issue information by your bank card, and it could be contain the who issued this card and how to communicate with this bank, and what about terms and condition, and what about the type of the bank card. And then with this information, and it will apply a visual card for your bank card, and in this time it will collect just pack your bank card number and with your password or the security code, and then do the Euro card. And then a new thread will be launched to do some waiting work. So I will talk later. And and in the same time, the Samsung Pay will request a one-time password for the identification and verification. And this is just a simple. You get your one-time password and input it and verify it. And so the key point for this progress is the wait push. But what they are waiting, they are waiting for this information, and this information was leaked on logcat. And so why this information is important? Because this information is critical for download your visual card. That the visual card is kind of applicate, and So the most important in this information is the SSID. And the SSID could be kind of a session ID provided by your bank. And this is unique for you to request your visual card applicate from the bank website. So, and another good news for this information is the SSID is quite long life. It can be valid up to 24 hours. So it gives the attacker a great opportunity to intervene this progress and to do some work or to do some debugging. So this is how we establish the communication using the this information. The first step, we have to initial connection to the Tsm service and in the Android level. And once the connection established, we can use the information here, the sign and the SSID and some others that doesn't matter. So use this information. We can just make our client to talk to Tsm service and to do some debugging or to know what's going on when downloading the visual card. So this is just general part of downloading. And the first is SE initialization, and the second is visual card applet download. And all of this is in this SE initialization, a new security domain was created by Samsung, and this security domain we can call it is supplementary security domain. And this domain was just a room that your visual card applet running in, and so that's the other part. But both of these progress was encrypted and saved by session key and SSL. So if we want to go inside this progress, we have to do something. And the first fact is traffic packet just encrypted, and we have to decrypt it. But I used the man-in-the-middle SSL attack. It didn't work, and so we have to do some internal probe on this system. So I need a root privilege. So what is secure root privilege? Because as I mentioned, the Samsung Pay is highly relying on his hardware-based system protection. So we need a root access, but we can't touch any the security protection to trigger any stuff we don't want. We want the Samsung Pay work properly. So we need just a root access without touching anything others. So the fact is Samsung Pay was launched with Android 6.0, but it works on 5.1. And 5.1 is vulnerable to some root tools and like Dirty Cow. And so we can gain the root access temporarily, but it's enough for us. So with the root access, we can do something. We examine the code of the Tsm service and SKMS agent, and we found some code snap that could be help us to get the plain test, because they're doing the log. They are doing all the log, but in practice, we can't catch the logs because they are disabled. So with the root access, we can do something. So let's first see the Tsm service. This is a code snap of how they control the log, and we trace the value where the value come from, and I found the value come from a JNI API JNI function method. So what's this? A disassembler this method is always return false. So if this return false and no log was done, so the best way is for us is just patch this lab and write it back to it, and this will not trigger any check. So that's the first trick to enable the debug log. And the second will be a little complicated. And as you see, the debug was controlled by two flags. And the first flag goes into the Android runtime lab and called is product shift native. And we can also use the trick before we used the previous, but if we want to apply the patch, we have to kill all the system and reboot the system, and then the patch will be applied. But with the second, it seems we can't do anything because the second is a read-only property, and we can't modify these properties. So it's always return 0, and the debug will be disabled. But SKM agent is shipped with the firmware, and there is no APK package inside the file inside the system, and it's just a ODEX file, and the system will execute the native code inside the ODEX and without compile the Delphi code. So let's modify the native code directly. So when we disassemble the ODEX file, we found these two jumps, and if we just patch these jumps, it will enable the debug log. But how can we apply the patch? Because dim verity is enabled, we can't change the files on the system partition. But files in Delphi cache is also ODEX file, and the system will load the Delphi cache if the ODEX doesn't exist in their directory. So, and if we remount the system partition and remove the ODEX file, it will not trigger the DM verity. So, sorry. And no integrity check for ODEX for native code. So that we can modify the native code, and it will not trigger any check. So that's the strategy to apply the patch. So you can just follow the do the patch and rename the file with the name convention, and just this. So with the debug log enabled, we have the detailed progress inside this registration, and this is all the steps they are doing during the registration. The first is, as you can see, the green line is done by SKMS agent, and the rest is by Tsm service. And the first 6 we call it is SE initialization, and the last one is to install the install your visual card. And all of these progress was secured by secure channel. So there are 3 keys involved during these steps. So unfortunately, I can't get any of these keys. So what I can do is just to go through what they are doing just from the pack. And the first step for this is just create a supplementary security domain. And this domain was created by Samsung. And the secure channel for this step is key ISD, and this is the ISD. I believe this is the same among all the device, and you can see this is the sample pack they send to doing this work, and once the client requests us to do this work, and the server will return some APDU commands back and put it into this field, and the client will send all of these commands back to the SE and wait for collect the results they execute, and once the result collected, and it will send back to the server and request the next set of commands. So this is how they do during the create the supplementary security domain, and it will just collect some information of your SE and install some applicant, and then set some keys. And the keys, the last step of set keys is the default key for your new supplementary security domain. And from here, and the TMS service will do the rest of the work, and it will just use the default key to just change the key to the key they only know, and then it will install the ARC client application into the SE. This application is to just allow the specific Android app to access SE. So that's another hardware-based access control mechanism inside this, and then you will do some personalized work on it, and then it will write the access rules for NFC access, and then some. This step is could be. I think this is just install the basement of your runtime for your card, visual card running. So this could be provided by your bank, and the last step is install your visual bank card. And in this, all of these steps is encrypted and by the secure channel, and all I can get is just to find just the brief way they are doing. So in this section, I got all the traffic and with some information leaks, but all of the other traffic packet was encrypted by the secure channel, and I can't get the secure channel key because it's only new by Samsung and your bank. So I have to draw the conclusion: your wallet is secure properly, and that's the reason why I'm using Samsung phone. So here are some sound bites for this. And I think the key ISD is just the root trust of this order system, and the key was used for triple dash, but I can't figure out what's the length of this key. It could be 128, or it can be 192. So I don't know. And the other keys are still important. If you get one of it, you can decrypt the rest of the packet, and there are mistakes and design fault by something and other developers. But with this, all of these, this is all we can know about. So I have to thank to my leader, Tom Keeper, and all the colleagues involved in this research and document and slides making. So thank you for you guys. Any questions?
So just going back to the user making a payment at the point of sale with the magnetic induction unit.
Sorry, I can't get you.
Okay, is that better?
Oops.
No, okay. When the user's paying at a point of sale using their phone, using the magnetic induction, if you were to stop the point of sale working, for example, using a telephone jamming transmitter of some description, because most of these things are based on GPRS, could you capture the token and then reuse it at another point in time?
I'm very sorry. I can't hear any word. Sorry. Oh.
Don't worry. It's okay.
Yes.
If you have any more questions, you could have a chat over tea and coffee outside. Thank you very much. Thank you.